So today we are going to solve LeetCode problem 2029 stone game 9. So in this problem we are given an array called stones and there are two players, Alice and Bob. So there are two players, Alice and Bob. Say Alice or play off first and then they'll take turns. On every turn the current player must remove exactly one stone. Okay, let's understand with example. Here we have stone of array 2 1. So here we have two stones 2 and 1. So the important rule is there is one common total sum of all the stones that have been removed so far. So this is very important. So let's play it. If Alice remove 2, so total become 2. So since 2 is not divided by 3, so Alice is safe. Okay, so this is Alice and this is Bob. Okay, so Alice is safe. Then now Bob has only 1. So if Bob remove 1, so 2 plus 1 is 3. So now the total becomes 3. So 3 is divided by 3. So Bob lose the game. Okay, Bob lose the game. So therefore Alice win the game. Okay, Alice win the game and Bob lose the game. So the answer is true. That's it. Let's take another example. 2. We have stone of array 2. See, if Alice remove 2, so the total become 2. So 2 is not divided by 3. So Alice is safe. But now no stone are left, so nobody lost. Okay, so the problem says Bob wins if all stones are removed without anyone losing. So here Alice will lose the game and Bob will win the game. Okay, so the answer will become false. If Alice win the game, answer will be true. If Bob win the game, answer will be false. Okay, let's take one more example. If we have 1 1 2, if Alice remove the first one, okay, so the total become 1. It was no, Alice is safe, but Bob remove the second one. So remember we use the one common total only. 1 plus 1 is 2. So now Bob also safe because 2 is not divided by 3. Okay, Bob also safe. Now if now Alice remove 2, so 2 plus 2 is 4. So 4 is not divided by 3. So Alice is also safe. Now all stones are gone. Okay, nobody lost. So in this problem Bob will win the game. Okay, so Alice is lost the game. Now see, so the problem is asking as one simple question only, can Alice win the game if both Alice and Bob play optimally? So our answer is true if Alice can win, otherwise our answer is false if Bob can win. Okay, so now how do we solve it? See, at first we might think we should try every possible moves and simulate the whole game, but that's a problem because if there are many stones, there can be many different ways Alice and Bob can choose stones. So we need a smarter observation. So see, the main observation is, see, total is divisible by 3. Okay, so we do not actually care about the complete value of the total, we only care about its remainder when divided by 3. So for example, see here, 3 is 1, so 3 is 2, so 3 divided by 3 is 0. If 4 divided by 3 is 1, then 4 5 divided by 3 is 2, then 6 divided by 3 is 0. Okay, see, every stones belong to one of only 3 groups. Remainder is 0, remainder is 1 and remainder is 2. Okay, see, why are this group useful? Because let's take, see, current, total, remainder is equal to 1. If we take a stone whose remainder is 2, like 1 plus 2 is 3, the new total is divided by 3, so player will lose. Okay, so player will lose. So similarly, current remainder is 2 and we take a remainder minus 1 stones, 2 plus 1 is 3 again, so player will lose the game. Okay, so see, 1 plus 2 is 0, remainder will lose. So 2 plus 1 is 0, remainder will rows. Okay, so this is a main interaction in the game. So what about remainder 0? See, suppose current total is 1 and we take a stone like 3, so 1 plus 3 is 4, so the total is still remainder 1. Okay, so a remainder 0 stone does not change the remainder, but it does something else. See, it use one turn, that's why the number of remainder 0 stone matters. Okay, so what information do we need? Instead of storing every stone separately, we can simply count them. Okay, count 0 number of stone with remainder 0. Okay, count 1 number of stone with remainder 1, and count 2 number of stone with remainder 2. Okay, so let's understand clearly. If you have stone of value 1, 2, 3, 4, 5, 6, okay, convert them. 1 remainder 1 and 2 remainder is 2, 3 remainder is 0, 4 remainder is 1, 5 remainder is 2, then 6 remainder is 0. Okay, see here, count 0 is 2. Okay, count 0 is 2, 0 0 is 2, and then count 1 is 2, then count 2 is 2. Okay, see, now the entire game can be understood using these three counts. Okay, now the winning idea is, now we use the important observation about the 0 group. If count 0 is even, okay, if count 0 is even, Alice can win win. If count 0 is even, Alice can win when count 1 is greater than 0 and count 2 is greater than 0. Okay, if count 0 is odd, Alice can win when if count 0 is odd, Alice can win when count 1 minus count 2 is greater than 2. So do not memorize this yet. So the important thing is why. See, let's try and then we get it. Okay, so stone of array we have 1, 2, 3, 4, 5, 6. So first one is 1, 2, 3, 4, 5, 6 multiplied by 3, 3 multiplied by 3, then multiplied by 3. So 1 remainder is 1, and then 2 is 2, then 0, then 4 is 1, then 3 is 2, 0. Okay, this is 0, 1. Now therefore, see, count 0 count is 2, count 1 count is 2, then count 2 count is 2. Okay, so count 0 now this. Okay, see, 2 is even, so use the even case. Count 1 is greater than 0 and count 2 is greater than 0, so therefore Alice wins. Okay, Alice will win the game. So the answer is true. So now let's take small example. Let's take a small example. Stone of array we have 1, 2, 3, 4. Okay, so we need 3 counters. First let's write down the code. We need 3 counter int count 1 is equal to 0, int count 1 is equal to 0, then int count 2 is equal to 0. Okay, count 0. Okay, 0, 1, 2. Because we need to count how many stones have remainder 0, 1 and 2. Now we go through the array. For int stone and stones. Okay, see, we check every stone one by one. Now we find its remainder, and rem is equal to stone stone mod 0 by 3. Okay, so see here, it means 1 modulo by 3 is 1, 2 modulo by 3 is 2, 3 modulo by 3 is 0, and 4 modulo by 3 is 1. Okay, now we increase the count. Now we increase the correct count. If rem is equal to 0, COU anti count 0 plus else if rem is equal to 1, then COU anti count 1 will increase, then else COU anti count 2 will increase. Okay, after processing the whole array, count 0 2 and count 1 2 and count 2 2. Okay, now we check if count value is a mod 0 by 2 is equal to 0. So see, I is count 0 even, here 1, here see, here 1 mod 0 by 2 is equal to 1, so count 0 is odd. Okay, so therefore we use ABS COU anti count 1 minus COU anti count 2 is greater than 2. Okay, see here ABS 2 minus 1 is equal to 1, and 1 is greater than 2 is false, so Alice cannot win. Okay, let's correct this code. First gemstone, then if count will increase, then we write this sign count, press if count 0 is even, then we write this. Yes, ABS count I think 0, wait, I have to write return also. Return COU anti count 1 is greater than 0 and COU anti count 2 is greater than 0. Okay, then we just return here ABS count 1 is greater than 0. Wait. Yes, it was very if else count, we have written this count stones based on their remainder when divided by 3. Count will increase, then if else remainder is equal to, then we just increase count 1, so in else we count 2 will increase. Then if count mod by 2 is equal to 0, if count 0 is even, so this is case dot case. If count 0 is even, right, then if count 0 is odd, let me fix this one more time. Count, okay, I didn't write 0. At 0 1. Oh, small mistake. Yes, see, so we go through the array one. So the time complexity is big O of n, and we only use 3 variables. In here we only use 3 variables, so the space complexity is big O of 1. Okay, Alice and Bob remove stones. Common total divided by 3. So current player loss. Small example we have take. Then yes, we have did this all things. Yes, that's it. Okay, it's very easy problem.